Welcome back to MPB's boot camp for the math portion of the ACT. I am Miss Killen and I am here to make sure that you get the best possible score that you can. So let's go ahead and jump into lesson 9. This is questions 21 through questions 25. So here we go. So the first question 21 reads, the rectangle ABCD shows segments BE and CE partition the rectangle into 3 triangles. Given DE equals 7 centimeters, BE equals 26 centimeters, and CE equals 25 centimeters, what is the length in centimeters for BC? So I'm going to go ahead and draw that for us just so we can have a visual. So we've got this triangle. Let me get me another marker. I was thinking that one was going to work, but it's not. So we've got this triangle, or excuse me, this rectangle right here. And I'm going to turn my light down so you can see a little bit more of the marker. All right. So we have A, B, D, and C. And then we have these right here, which are made with E. We do need to know that this is 7 centimeters. This one's 26 centimeters, and this is 25 centimeters. Now, one thing that we know about a rectangle has what type of angles? Exactly right. All of its angles are considered right angles. So these triangles that we made, this one right here, down here at the bottom, this triangle down here, and this triangle right here are right triangles. So we can use that to our advantage to find the different amounts. So let's go ahead and try that. So the first thing I know is, let's look at this triangle right here. Let's see if I can get it a different color so we can have a little bit more clarity to what I'm talking about. So let's look at this orange triangle right here. That is a right triangle. So I know that this is 7, this is an unknown, and this one is 25. So anytime that we look at right triangles, I know I have the Pythagorean theorem. A squared plus B squared equals C squared. And we know that C squared is always the opposite side of the right angle. So let's go ahead and plug those numbers in. So we have 7 squared plus an unknown plus 25 squared. Now, let's make that just a little bit prettier to work. So I have 49 plus B squared equals 625. If you need to double check your math, you're going to do 25 in your square button, which gives me 625. So then let's go ahead and try to get our variable by itself. So I have 625 minus 49, 576. Still don't have that variable by itself. But you're thinking, it's on that other side, but it's not. It has a square. So to get a square going, I do take the square root. So my B, which was down here, the square root of B, and we take that square root, is going to be 24. Now, what do I know about rectangles? We know that rectangles, the opposite sides are what? They're equal. So if this down here is 24, this up here is what? It's 24. Now, it wants to know what this side is. All right, so I need to figure out if from here to here is 7. I need to find out what this measurement or that portion of that triangle is. So let's go ahead and work to see if we can figure that one out. So again, I'm going to do this one in green. I've got A squared plus B squared equals C squared. All right, so go ahead and plug in what you know about those measurements. So I know that my C squared is 26 squared. Let's say that B is my 24, and still not quite sure what that A is. So y'all, I'm going to dim the lights so you can see. Let's go ahead and work those and see what we get. So 24 squared, what did we say 24 squared was? It is 576. 26 squared is 676. Still not quite sure what that A squared is. So let's go ahead and isolate that variable by subtraction. So I have my A squared equals what? 100. Still got to isolate that variable. So I'm going to take my square root and A equals 10, that means this portion right here is 10. Now, we know that this side and this side are congruent. So from here to here, let me get a different marker. From here to here is 7, and from here to here is 10. I add those together, and that side from B to C equals 17. So what is my answer? My answer is going to be C. Good job, guys. It's going to be C. All right, so we need to make sure that we are reading what we need to answer. Just because we get a measurement does not mean that we have answered the question that the problem asks. So as I erase this, let's go to our next question. And it says, in a particular cleaning solution, the ratio of concentrate solution to water is 3 to 40. How many cups of concentrated solutions should be added to 5 gallons of water to make the cleaning solution in the given ratio? Now there's a note, and we have to take consideration of these notes. They are giving them to us to help us. And 9 times out of 10, those notes are something that we need to remember from those essential skills that we have already learned. So let's go ahead and look at that. It says that 4 cups equals a quart, and 4 quarts equals a gallon. Now, in elementary school, middle school, maybe you learned the Gallon Man, maybe you learned a little song, whatever. You need to make sure that you're remembering those essential skills to work this problem. So I'm going to dim the lights a little bit so we can see the board. So I know that I have a 3 to 40 ratio. And I know I'm looking at cups and I'm looking at gallons. All right, so the next thing I need to do, I need to change my gallons to cups. So let's just use what we've got and work our way through it. So I know that 1 gallon equals 4 quarts. I know that 1 quart equals what? What did it say? 1 quart equals 4 cups. All right, so let's think this thing through. How many quarts takes a gallon, which is 4, but how many cups are in those 4 quarts? So let's see. If 1 quart is to 4 cups, then 4 quarts is an unknown. This is just one of those is and of problems where I cross multiply and divide. And that means 16 divided by 1 is going to be 16. So in 4 quarts, there are 16 cups. All right? So that means in 1 gallon, there's 16 cups. But Miss Killen, we're not using 1 gallon. You're right, we're not. We're using how many? 5 gallons. So how would I find the cups to 5 gallons? I'm going to multiply. So I'm going to take that 16 times 5, and I get 80 cups in 5 gallons of water. So now that we have this information, let's see what we truly need to answer. It says how many cups of concentrate solution should be added to 5 gallons of water to make the cleaning solution given in the ratio. So here we go. I've got 5 gallons, and as we learned, I'm going to multiply it by those 4 quarts per 1 gallon, and that's going to be 20 quarts. All right, so then my 20 quarts times that 4 cups, not 40, in 1 quart, that's going to equal 80 cups. Now, we've learned how to do this in our younger math. So it does check out. Both ways show us we've got those 80 cups. So now I need to look at that ratio. So I'm going to erase this side over here so I can do the work over here, knowing that we have double checked the amount of cups in that 5 gallons. So here we go. So I need to know an unknown. I need to know an unknown. So I know that my 80 cups times my 3 to 40 ratio is going to equal what? Well, when I multiply a fraction, I multiply straight across. So I have 240 over 40. Always reduce that. So 24 divided by 4 is what? So I'm going to need 6 cups. So what's my answer? My answer is G. So we need to make sure when you are doing these conversions, always double check yourself, because if you can do the conversions incorrectly, you're always going to get the wrong answer. So that's why we double checked our conversions. One way and then another way that we maybe had learned in a previous math class. So good job. Our answer is G. So let's go ahead and look at our next problem. Okay, here we go. Let f of t equals 3 Euler, 7 Euler to the 3t power plus 1. Which of the following number is closest to the value of f of 5? Now, you're like, I've never done the Euler rule. That's okay, because this Euler rule is super simple. So, what we're going to do is we're going to look at what they've given us and see what we need to do. So, they have given us, I'm going to, so you can see a little better, f of t equals 7 Euler rule to the 3t power plus 1. Now, I want to know f to the 5th. So everywhere I see a t, what am I going to do? I am going to put a 5. So let's go ahead and rewrite that. So f of 5 would be 7 Euler rule, 3 times 5 plus 1. Now, there is a super simple way to do this. Super simple way to do this. What I want to do is I want to go into my calculator and do this, all right? So let's go ahead and pull up that calculator. All right, so we are pulling up. Here we are. So now, here's our calculator. Now, you're thinking, I've never done with the Euler rule. And we know the Euler rule, if you don't know, I'm going to tell you, deals with irrational numbers. So that's what we're going to do. So the first thing we're going to do is go to our y equals. All right, so we're going to look at that y equals. And in that y equals, we're going to put 7 Euler, which is second, and then this in right here by the 4 is where we're going to put it. It's right here, so it brings that Euler up. Now I'm going to put a parentheses 3 times 5, close parentheses, get out of my exponent and add that plus 1. All right, so it should look, when you put yours in, something similar to this. Now, the next thing that I want to do is go to my second graph. And then here it is. That's what it looks like. 2.29 or 2.28, depending on how you're looking at it. So now that I've seen that, I'm going to look over here. I don't see anything like that, but I do see our scientific notation. So I'm going to go back to y equals, and each one of these I'm going to put here and see which one looks the same. So I'm going to go down to y2, and I'm going to put -2 times 10 to the -1. So I've got, let's pull this up a little bit. I've got -2 times 10 to the -1. So my next one, y3, is going to be 3 times 10 squared. My y4 is going to be 2 times 10 to the 7th. And then my y5 is going to be 6 times 10 to the 7th. All right, so now I want to pull that same table up and see what I got. So let's go ahead and try that. So I'm pulling my table, second table. Now, you may be saying, Miss Kellen, I don't see what you're talking about. All right, well, let's look. For 1, if we scroll over all the way to 1s, we have 2.9, I have negative, that's not going to be it. I have a whole 300, that's not going to be it. 2.7 or 2 to the U or 7, that could possibly, and then that one, that's nowhere near. So if for my entry is this number, 22883,112, which is what? 228,832,000. Nope, that's not it. 123. Okay, that's 22,883,122. So then this one over here, that's not it. That's not it. That's around that 20 million. So I could say that this pink one is roughly what my Euler rule was with irrational numbers, remember. So I'm going to go back and see which one was the pink one, and my answer is letter C. So that's how we use that irrational number and plugging it in and see what those look like and see which one is the closest. And that's a skill that we're going to learn later on in the boot camp of picking and choosing with our numbers. So we would say that our answer would be C. That's a good job, guys. We really looked to see how we could use those picking and choosing skills. All right, so let's go to the next one, which is 24. Okay, which of the following expressions 40 degrees in radians? So what we need to do is we need to do our 40 degrees in radians. So again, that is going to be a calculator skill, so let's pull up our calculators. Okay, so our calculator is here. Now, one thing I want to tell you, a lot of you are saying, Miss Kellen, I know how to do this. I don't have to use the calculator. That is true. I want you to know that there is a degree of function on here. So let's get out of here. And we do have the degree symbol. Nope, didn't hit the right one. So we do have the degree symbol. Still didn't, there we go. So we do have the degree symbol right here. So you can go from degrees to radians in the calculator. But sometimes it gets confusing with all of those. So I did want to show you where they do have that degree symbol. But for this problem, it's probably going to be easiest if we do it pencil paper. So, like I said, I wanted to show you where the degrees was on the calculator. So there is a skill. But let's go ahead and just do it old pencil paper way. I know some of us like that better anyway. So let's go ahead and try it that way. All right, so here we go. So I know, just going from the classes that I've taken, I am going to multiply the degree by the conversion fact. Conversion fact. Now, Ms. Killen, what does that mean? All right, so we know 1 is the same thing as pi over 180. We know that. We've learned that in geometry. Maybe y'all touched on it in trigonometry. So I'm going to take my degree and multiply it by 1, which is pi over 180. So this would be degrees. This would be radians, or rad as we call them. So what happens when I multiply what happens when I multiply fractions? I multiply straight across. So I have 40 pi over 180. Ms. Kellen, I don't see that. You don't. So let's go ahead and reduce this fraction. I know I can reduce the zeros off of it. So all I've got to do now is reduce 4 over 19. Well, both of those are what? They're even numbers, so I can divide by 2. So I have 2 pi over 9. Do I see that as my answer? Yes, I do. My answer is G. That is true. Good job, guys. So let's look at the last one here for this problem. I'm going to erase while we read it. So it says, let the function f be defined as f of x equals negative 9x squared. In the standard xy coordinate plane, the graph of y equals f of x undergoes the transformations such that the result is the graph of y equals f of x minus 4. Under the transformation, the graph of y equals f of x is what? Now, let's remember some things that we have learned about transformations. My x is inside, all right? Y equals. If I add or subtract on the outside of the parentheses, I am moving what? Up and down. If I add, I'm going to go up. If I subtract, I'm going to go down. Now, what happens when I add or subtract inside of that parentheses to my x. If I add something to my x or subtract something to my x. That's right. If I add, I'm going to go left. If I subtract, I'm going to go right. If we look, we have y equals f of x minus 4. Well, there's nothing inside that x, so I'm not going left or right. I can only go vertical on the outside. So since it's a subtraction, I'm going to go down how many units? Exactly right. So when I look at these, I'm going to shift downward 4 coordinate units. So we need to make sure that we are reading exactly what the problem is and then what the possible answers can be. Guys, I have had a lot of fun doing these problems with you. I know that as we go more and more, they get a little bit more complicated, but that's okay because we're going to learn some techniques and some strategies to help you with those complicated problems. So as always, remember for this AC portion of the math portion of the ACT, you want to make sure that you are practicing. I am Miss Killen. I want y'all to have a